The tech in the investech sector really comes in two flavors. There are a lot of new technologies that make the investment process more efficient and more accessible. We've seen some of that in the first module of this course. Automation in asset allocation, financial planning, and security settlement have really started to drive down costs across many investment sectors and enable new developments like robo-advisors, automated financial planners, and smart index funds to make the average investor's portfolios more customized and more diversified, and at the same time, less costly. The other category are the technologies that make the investment process more precise. And these are broadly labeled, sometimes incorrectly, as AI, big data, and machine learning technologies, which are simply data analytics tools that enhance our ability to interpret the historical financial data and make more accurate predictions for the future. We've talked about some of these, such as neural networks, primarily from a technical point of view. In this module, we'll take a broader, business-focused point of view on the application of AI and machine learning techniques in the investment industry. We'll take a primarily non-technical approach in this module, with the goal of providing an industry overview, demystifying the key buzzwords and clarifying some common misconceptions, providing some practical advice, and directing you to the more in-depth research and analysis in the relevant subject fields such as computer science and statistics, should you be interested in pursuing further. First, let's take a look at what AI and/or machine learning really are, as these concepts are probably on par with crypto as some of the most overhyped terms in finance. First of all, there are two types of AI systems. One is called narrow AI, which, as defined by Dvorsky, is a computer system that matches or exceeds human intelligence, but in a narrowly defined area. Under this definition, most computer programs can be called narrow AI to some degree, as most of them would exceed humans' capabilities in some area. Next, the general AI is probably the one that you're more familiar with, and that's essentially the Skynet. It's a software, but without the pre-programmed rules. An artificial neural network that is truly able to code itself and rewire itself with new data patterns. Essentially, the general AI is a true imitation of the human brain. So far, the current computing capabilities of our hardware is far from being able to even remotely construct a general AI network. So most of the research in this type has been theoretical. Therefore, the current application of all of the so-called AI systems in finance has been at best narrow AIs. A more appropriate label for AI in finance, though, is probably machine learning. You see, the financial industry, particularly the investment sector, has been all about processing data and information, extracting new insights and signals from current and historical data. In these settings, the use of AI has essentially been the use of more and more advanced models of machine learning, which itself is a fancy buzzword for statistics. Essentially, using machine learning, or quote-unquote AI in investments, is using advanced statistical models on the same financial data to better interpret patterns in the data, conduct better statistical inferences, or make better predictions. Now, let's put the tools and the data together to have a more complete picture of the type of the data out there in the investment landscape and the type of tools that you can use on them. First, there are all kinds of data that you can use to guide your investment decisions out there. Numbers, reports, text, news, you name it. Now, these data will belong to one of two types. Let's call the first type, quote-unquote, small data. These are the data small enough in size, like files and Excel spreadsheets, that you can store on your computer and search on your computer. And the counterpart to that is big data. And what's big data? Well, data set that's large enough that you can't store it on your own computer, but instead have to put it in a dedicated storage server and have to use some specialized database tools like Hadoop and MapReduce to efficiently process and manage the data. That's it. That's literally the buzz-free meaning of big data. Now, within both the small data and big data categories, data can further be classified into two types based on their structure. The first type, is called structured data. These data are essentially numbers that you can organize neatly in rows and columns like in an Excel spreadsheet. Not surprisingly, it's a little easier to perform analysis on structured data because they're already quite organized. In contrast to that are unstructured data. These are the natural languages, texts, images, videos, etc. Because these data are not neatly stored as numbers in rows and columns, they will take a little bit more effort to analyze. First, we'll have to use some statistical technique like natural language processing or NLP for text data and signal analysis for audio and video data to convert these data into numbers before we can analyze them. But the important thing to note here is that, contrary to what you hear in the hype, there's no mutual exclusivity between the data types. For example, not all unstructured data are big data. Things like text or image files could be very small in size, so you wouldn't need MapReduce to work with them. But they still require the extra processing step to be converted into numbers. There could be small unstructured data, and there could be big structured data. Now, with all that data available, here are all the tools that you can use to mine these data for insights and signals. Starting with the simplest, we have what I call the simple analytics, like basic summary statistics. For example, averages, standard deviations, correlations, etc. Now, basically everything else can be labeled as machine learning, which again is just a fancy buzzword for the more advanced statistical models beyond simple statistics like averages that you can use on the data to analyze patterns, conduct inferences, or make predictions. Next, there are two types of machine learning tools. The easier type, let's call that quote-unquote shallow learning. A classic example of shallow machine learning is a linear regression. Shallow learning is essentially a statistical model where we, the user, have to specify most of the model parameters. For example, when you're estimating a regression, you have to choose what are the independent variables, the regressors, that you want to include in that regression. The counterpart to that is deep learning. And the buzz-free meaning of deep learning is essentially a statistical model with more parameters that can be directly determined by the data. An example of deep learning is regularized linear regressions like the lasso or the elastic net. These are the regression models where, instead of you choosing the independent variables, you load the entire variable list to the model, and based on some basic criteria, the model will choose the most quote-unquote important regressors to include for you. That's essentially deep learning, letting the data determine the model parameters. From the last module, we already saw that neural networks are another classic example of deep learning. And this class of models is the closest to quote-unquote an AI that we can use for financial data analytics. And further, within each machine learning type, we also have two subcategories. The first category is called supervised learning. And as its name suggests, supervised learning models have to be trained with data before we can use them for tasks like predictions. Again, a linear regression is a classic example of supervised machine learning. Recall our lending regression examples from the credit tech class. Any regression model there has to be fitted with data first. We need to get the parameter estimates for these alphas and betas, and only then can we plug in new data and get the predicted values like the default rates. By this token, you can view other much more advanced supervised learning models as super souped up regressions. The other class of machine learning models are unsupervised. This means that we don't need to use existing data to estimate the model before we can use it. We can just directly use it. A classic example of unsupervised learning models is clustering. Given a bunch of data points, you can directly take them to a clustering model, and the model will cluster them into groups where points within a group are close enough. We've seen a model like that in action in the platform lending module of the credit tech course. So basically, both shallow learning and deep learning can either be supervised or unsupervised. Finally, to put the data and the analytics together, well, you have complete freedom to choose whatever tool you see fit to analyze the type of data at hand. You can use a supervised shallow learning tool like a regression to analyze structured big data, and there are unsupervised deep learning tools for unstructured small data. When it comes to using AI or machine learning for investments, you're really limited by number 1, your computing power, and number 2, choosing the most appropriate model that works best for your data type and your questions. Let's now take a deeper look at the usage of unstructured data in investments, because with the competition for alphas getting more and more intense, investors are increasingly turning to the analysis of unstructured financial data and are using ever more sophisticated models to mine them. If you think about it, in finance, the bulk of the growth in data that we have available has been in unstructured data. This is from Apple's SEC 10K filing, its annual report for 2019. And this income statement here is an example of structured data, with numbers neatly stored in columns for tabulation and analysis. And when released, these data are obviously the first focus of analysts and traders alike. However, think about how long this annual statement is. The tables are only a few pages at best, and the rest of the statement, the hundreds of pages of text, is all unstructured data. Much fewer people pay attention to these, not to mention finishing them, as they're not very exciting reading. But these languages might contain a lot of information. What words and what sentences are used, and how they're put together, can tell you a lot about what the management might be thinking beyond just the income numbers. Same for the social media data. This is a random Twitter page with posts about Apple stocks at the end of 2019. As you can see, these social media languages, how positive or uncertain they are, for example, can also tell us a lot about investor sentiment and psychology around the stock. Of course, there's way too much of these unstructured data, text and images, that are relevant to the stock out there for us to read them all. And that's precisely where computers can help. For example, we can use natural language processing tools to first convert the text into some form of numbers that we can fit our existing machine learning models on. At the simplest level, for example, the whole 10K filing could be turned into a word vector with entries denoting to the frequencies of each English word that's used in the document. We can then stack different document vectors together into a matrix and run all sorts of shallow and deep machine learning algorithms on it to get an estimate for both content and context, like how positive the languages are, how complex the sentence structure is, how many topics are talked about, among many other things. So I encourage you to explore a bit more about natural language processing and other methods for unstructured data analysis, because when used appropriately, they can really extract information and signals from these data that are truly incremental to what you get from purely the numbers.